So this video is the continuation of part 2 of TDD using Munit. So as seen previously, we wrote unit test cases for getting getting prime products and non-prime products depending upon the ID of the person being passed. So we have 4 test cases covered. Now since in previous videos we saw how to get the values from the actual database, but in real scenarios, test case should never depend on the actual database. Instead, it should mock the database. So in this video we'll see how can we mock the database, and also try to understand the behavior of spy. So let's start with a mock first. So we'll try this mock on non-prime products, which is the third test case. So let me select mock when. Now I have to select a processor, pick processor, and I'll for the first select I'll click on it. Now if you can see, there are 3 parameters to choose from. I mean, how do we confirm, because there are multiple select, right? So it asks us attributes for select, which select are you trying to refer to. So usually we should change the name so that we can uniquely identify. Keeping this doc id, using that this doc id is not a wise idea, because tomorrow if you happen to change the code and suppose you delete the palette and then again insert it, there are chances that the doc id of that particular palette would change. So instead you should refer the doc name and give it some sensible name. So right now we haven't named it properly. Let's name it so that we can select that name to mock. So I'll write as get employee, get your user, or get prime status. Okay, so this is the name of the doc, and I'll change this to get products. Let's rename this as well. Extract prime status. Okay, so now if we go back, we'll select a processor. It's get prime status, right? So I'll select it by doc name. So now this makes much sense, and we have selected, if you can see here, doc name get prime status, and so this is the one that would be mocked. Now what would happen is we need to return, right? When this processor encounters, instead of running the actual processor, we have to mock its response. So how are we going to do that? It's simple. We'll just invoke. So ideally your select statement would return you a Java object. So that is what we are supposed to return. So how are we going to do that? We can do it by, let's create, we can use a DWL. So let's create a new file, and it's users.dwl. Let's hit on finish. Okay, So let's create a DWL. DW 2.0 output would be application Java, because we want a Java object, right? So it's application Java. Okay, next I'll return detail of customer prime is okay. That was for non-prime, right? So prime should be n. So it's saving it. Yeah, so it has been saved. Now I'll call the file read URL. Okay, so in read URL I'll read the DW file. It's class path users dot dwl, and let's change the media type to application Java. That's it. Now I'll ignore other test cases. I just want to focus on this test case alone, so I'll ignore it, other test cases. Okay, so I've just mocked a single, I mean the first select, the other one has not been mocked. So let's see if it works right now. So if you can see, the test case executed successfully, meaning the mock that we implemented worked, right? So if you go over here and if you see, okay, so the flow has been executed. Now I would like to mock the second. Okay, let's mock the second one. Let me create a products dot non-prime products dot dwl, non-prime products dot dwl. Just a matter of copy and paste the whole thing, and then I already have non-prime products dot json, right? Just copy and paste the whole thing over here. There it is. So I have copied and pasted it. Now let's add one more mock, and this mock is going to work on the second processor, second select, right? So this is the get products select. Okay, I'll select it by doc name. Okay, next is value. I want the value in payload, so payload would be read URL class path, it's non products dot dwl. Okay, and the media type is application Java. So yeah, we have configured the second mock, and let's try to run. So now if you see, it still works, right? So we have successfully mocked both the select, right? So but now you might be wondering that there is a chance, how do we assure, how do we really know that if these guys are working both the mocks? Because you might be thinking that it's actually hitting the database. That could be the case. Yeah, that's obvious. That's fair enough. So what we'll do is, if I suppose if I change this user.dwl to prime, okay, let's make this as y. So what would happen is, it would search for prime product. Okay, so now a y would go, and in this query, okay, it's going to search for prime products, right? So it's going to search for prime. Now I won't mock this. Let let this mock be ignored. Okay, and what would happen is, if I don't mock this, it would hit the actual database, but from here it would come as prime would come as n, because I've changed it, right? I've changed it to y. Okay, so the y would come, uh, I mean it's going to ask for yes, and then this would actually get the list of prime products. Okay, prime products, but this test case is for non-prime. So it's actually expecting non-prime products, but it's gonna get prime products. If I remove the second mock, if I remove this mock, I'm going to get a list of non-prime products, a list of prime products. Okay, so let's see this. I'll remove this mock. Let's just get rid of this mock. Instead, I'll let's just place it over here for the time being. So now what's going to happen is, the first database palette, this is going to be mocked. Okay, this won't be mocked, and the test case is for non-prime products, so it's actually expecting non-prime products. But since the mocked users.dawl is sending prime as y, so it will bring the prime products, which is not the expected one. So this test case should fail, and if the test case fails, then we would be assured that this mock is actually doing its job right here. Okay, it's just to show that it's actually working. We haven't done any mistake in the configuration. So let's see, this should fail. So if you can see, the test case failed, because see, it got a different payload. So obviously, if I send a prime status, if this being mocked and it sends it as y, then what would happen is it would get the list of prime products, but this test case validates against a JSON which contains a list of non-prime products, so it failed, meaning our mocks are working properly. So now that we have understood that our mocks are working fine, it's not actually calling the database but getting mocked. Let's try to see how spy works. Let's see. Okay, we have this spy, and uh, let's adjust this before call. So I want to spy this transform message. Okay, so before this transform message, what would be the payload? There's going to be no payload. It's just blank JSON, right? Because this payload is Java. Okay, so but just for ease of understanding, I'll make it as JSON. Okay, now so it would be a blank payload, just two braces open and close. Okay, and but after this transform, depending on the condition, so now since this is a non-prime test case that we have applied to, we'll have a list of non-prime products, right? So we can use this spy. Let's configure this spy on a processor, and the processor is transform message, right? So even here we should be renaming it. Let's rename it. Let's make it as list of products. Okay, now before call, let's assert that. Okay, equal to and one more assert that. Let's copy it from here because this is the thing we want to assert in after the processor. So this is payload, and let's pick the processor, list of products. Okay, so we have configured the spy. Now let's try to run and see if everything works fine. So our test case has failed, and if we see the reason, it says that it got the list of non-prime products but as a Java object, but it was expecting two curly braces. So there, what we did wrong over here was we considered only this transform, but we forgot to see that the database would return an object, so the payload would be an object, a Java object. Okay, so the assert that we wrote was incorrect. So now what we should be expecting is we should be expecting a Java object, right? So let's call the DWL that we had for mocking purpose non-prime products dot dwl. And now let's try to run. So again our test case has failed. Let's see what went wrong. So now if we see, it's complaining that it expected class path. Okay, it was expecting this string. Okay, so most probably we have made a mistake in assert that, and it's good to make mistakes so that at least we come to know what went wrong, right? So this equal to, consider this as plain string, but we actually want this class path URL to be read and the file to be picked up from here. So what we missed is read URL. That is what we missed out, and that's the reason it was failing. Now that we have fixed it, this test case should pass. Let's try. Okay, so the test case has passed. Okay, so we have now configured the spy properly, and we are able to verify what was the payload before this processor and what was the payload after this processor. This is how you can configure a spy to check the before and after conditions of payload, of attributes, or anything that you want to check in spy. Now if you see in the test cases that there's some redundancy. If you see these two test cases, okay, so what you can see is the set event is used in both, right? And also the in this it's different, but in this set event is being used twice, and it's the main requirement. It's the test case starts with the set event. So in such cases what you can do is you can have one common point for this set events, and that would load before your test cases start. So for that we have some very good utility called before test, before suit, after test, after suit. Okay, so if you see, you also have after test or after suit. So let's just try with before test. And let's put this set event. So now this would execute before the execution of any test, right? Let's try to run and see. So the test case has again passed successfully. So in this way you can use before test, before suit, after suit to put a common place for all the redundant processes, right? Like set event was redundant because it was being used in both the test unit test, right? So what we did, we kept it in one single place, so you can remove in other test cases as well. So it makes a one central point and improves the readability of your test case, right? So this is what how you can use before test, before suit, after test, after suit. So I've also pushed this code to GitHub, and you can also refer this code from there. And for ease of understanding, I have made several commits in this repository, and it's like first failure. I It's test case wise. I've included the failure. First, there is a failing code, then there is a passing code, then there is a second failure code, then there is a second passing code. So in this way I have made the commit so that you can get a better understanding which commit version has which, so you can individually load different commits and understand. So that's it for this video. I hope this video has given you some amount of understanding how can you implement test driven development in Mule as well. It's already being implemented in other languages like Java, C++, or other languages, but in Mule not many people implement test driven development. So I hope this series of 3 videos might have given you some idea how do you implement test driven development, and I've also explained quite a few basics of munit. I hope this video helps. Yeah, and thanks for watching.